with multi-step problems. So you are going to talk about going from particles to mass, or from mass to get to your liters, or from liters to your molecules, however you're going to go. Multi-step problems are always going to start with division and end with multiplication. Alright, so no matter what, always starts with division, always ends with multiplication. Now, just as a reminder, I want to do one that is talking about your one step. So if it says we're going how many atoms are in of copper, so C2 are there, or Cu2 in 5.6 moles. So it's a two-step problem, but it only really involves one of the steps that we talk about with the mole. So that you're not multiplying by the moles more than once, because you have the moles already here. So in this case, because we are going to something, we're going to multiply. So we need Avogadro's number for this particular problem. 6 times 10 to the 23rd atoms, or molecules, because we have to get to atoms of one specific thing. So first we need to find the molecules of the whole thing, because according to this, so for every one molecule of Cu2O3, so copper oxide, or copper 3 oxide, we are going to have 2 atoms of Cu, according to what we are given in our particular formula. So first we need to find the molecules, because for every one molecule we have 2. So we're going to take this. We know this is what we have, so we don't need to worry about anything with the numbers, because we know this is going to equal times 10 to the 23rd after it's all said and done. Now, for one molecule, we have 2 atoms, so we can put that in there. So we can get rid of the molecules after we do our math. So we take our 5.6 times 6.02, and then we can multiply that number by 2 to give us an answer of 67.4 times 10 to the 23rd atoms of Cu. But remember, because of scientific notation, we need to move it over 1, so technically our answer is 6.74 times 10 to the 24th atoms of Cu. Alright, now let's do a true two-step instead of just having that extra add-on there. How many grams of sulfur are there in 3.45 times 10 to the 22nd molecules? So we're looking for grams, and we have molecules. So that means we must start with our 3.45 times 10 to the 22nd molecules, and we're going to get to moles, because moles are the middle ground. We have to get the moles first before we can get to grams. So we have 6.02 times 10 to the 23rd molecules, and we can do the math, or we can go on to the next step, which our next step is going to be finding the grams, or the molar mass, of SO2. So I have to find S, which is 32.1, and I have O2, which is 2 times 16, which gives me an answer of 32, not 36. So 32 plus 32 gives me an answer of 64.1 grams for every 1 mole. So now that I have this answer, I can figure it out with my math. So remember, if I have 3.45 times 10 to the 22nd, and I have 6.02 times 10 to the 23rd, and I'm dividing, I can split this into two. I can divide these two, and I can subtract my exponents. So whatever this answer is times 10 to the negative 1. So 3.45 divided by 6.02 gives me an answer of 0.57, which I can do one of two things. I can either move the exponent over and make it 5.7 times 10 to the negative 2, or I can move it over another place and just have 0.057 for my moles. So this answer basically goes right here. So we move this answer there to show that we're going to multiply this by 64. So we'll multiply this by 64.1, and that gives us a total answer of 3.67 grams of SO2. All right, and that is the total work for this answer. So you will need to make sure you practice this, because the practice makes perfect. If you know how to do this, it's not so bad. If you know how to do each step, it's just adding them together. All right. Now, if you have any questions, please email me. It can be tough. You might want to make sure that you do all the practice problems and maybe some more just to get used to it. All right. Have a good day.